Alright, you guys, this is video E4.1-2. Explain the features and processes of groundwater systems. Puts. So basically we're talking about how long stuff stays in an aquifer, what might be recharging it, meaning putting more water in, and then overall what's going in as opposed to what's coming out. So you should be looking at this set of notes here, and I'm going to go ahead and start the PowerPoint to get us rolling. Alright, groundwater and aquifers. So we had three leading questions there on the front page. What's groundwater and why is it important? What is an aquifer exactly? And how is groundwater affected by human activities? So first off, groundwater definition. Water that's held in pore spaces, or I should say open spaces, which are pores, we'll call them pore spaces, in soil or rock. These are the little spaces between each granule of, say, sand or gravel, a certain type of rock, something like that. So rainwater percolates into earth. Soil and rock are like a big sponge full of holes, and this is where it will end up collecting. Remember, pause as you need to, you guys. So below the water table, these holes are full of water. So the water table is kind of the surface of our underground water, the very uppermost portion of it. Okay, so in my diagram here, we have some precipitation up top and infiltration, and we can see this is a fractured rock aquifer, and water will actually go through and below the water table. It will occupy all these cracks or fissures or fractures in the ground. Over here in the sand and gravel, though, it's going to infiltrate through, and we'll just take up all those little spaces between these pebbles and granules and things like that. And you can see, right here is my water table. That is the line which is the top of the, we'll call it the groundwater zone, where everything below it is every little space is filled with water, or we call it the saturated zone. Above that, between the surface of Earth and the water table, is the unsaturated zone, because sometimes there's water in these spaces, but it's just passing through. So generally, it's just air. So how much groundwater is there? It says there's about 30 times more groundwater than surface fresh water. We talk about how groundwater is like a bank account. In other words, a certain amount goes in, which means we can only take a certain amount out. Okay, my grandfather used to call this the 50-51 rule. If you make 50, you can't spend 51 because you don't have that extra dollar. So for this, nature makes deposits through rainfall. We get infiltration down to the aquifer, and then withdrawals through leakage of groundwater to streams in the ocean. So it's actually a groundwater discharge to surface water bodies. Our wells represent further withdrawals. So every time we put a well in the ground, we're taking water out of the ground and taking out things, water that was deposited there by nature. So at the end of the day, last sentence here, if total withdrawals exceed deposits, we deplete our groundwater storage. Just like if I keep taking money out of my bank account, I'm eventually going to have none there. Okay, I will dry it up. Same idea here with an aquifer. So on the left side here, so above you'll see an example of what takes place with when deposits exceed withdrawals. Okay, so meaning we have plenty of water. More deposits are going in than we are actually taking out of the system. Okay, it says okay, so we are at a happy place here. Okay, the fish is happy, there's plenty of water, the water table is remaining steady, we're in a good spot. We are not dropping our water table down lower and lower and lower and lower. On the right hand side, it says you'll see an example of what takes place when withdrawals exceed deposits. So we're over pumping, we're taking out more than is actually going in. And you can see that the water table has dropped. Poor little fish here is now probably dead because the water's gone out of the stream, and we've dried up this well on the left-hand side. This person here, if that was a private well, one of our homes here in Hamilton, you don't have any water anymore. And this happened, I was told by some students not too long, well, maybe several years now, but I believe by Dykeheist Farms, they accidentally, when they dropped the irrigation well, they overpumped and dropped the water table, and some surrounding homes, their wells went dry. And so this was an accident, of course, and Dykeheist Farms took care of it and drilled their wells deeper and you know, said sorry and all. So it was no big deal, but that is a very real thing. It happens when we are taking more out than is going in. So water table definition is the top part of the groundwater zone or zone of saturation. Remember, I talked about this. This is where all the little pores between the particles underground are full of water. When the water table meets the surface of the land, those are lakes, streams, swamps. I talk about going to Lake Michigan to the beach, and my kids always want to dig a hole right there, you know, well, maybe 10, 15 feet from the water. Eventually what happens? We get to water, and the hole starts caving and everything. We've dug down to the water table, but if we just pick our heads up and look 10 feet out towards the lake, there is the water table. So it should make sense that water is so close to the surface near lakes like that. This is the same reason why people who have homes on lakes don't have basements that are below grade, that are below the ground, like most of us would have in our homes, because the water table is too high. So again, here's the water table. We'll see this diagram probably again and again and again. And we see that this particular stream here, that is recharging our aquifer, because this stream is above the water table. Now if this dashed blue line were up here, it would go the other way. Groundwater would recharge the surface. But in this case, the surface water is recharging the ground because it's above the water table. Just as in your notes, you'll find this picture. Label the following parts on your diagram and your notes. Okay, the unsaturated zone from the surface to the water table, the groundwater zone from the water table on down, which is the zone of saturation, you guys. It's the same exact thing. You'll see it called both, so I want you to make sure you label it both. Groundwater zone is the zone of saturation. And then the water table, which separates these two zones. The water table separates the unsaturated zone and the zone of saturation, or the groundwater zone.